In this video, we're going to go over an introduction to functional groups and the hydrocarbon functional group. So organic compounds that contain atoms other than carbon and hydrogen, otherwise known as heteroatoms, such as oxygen, nitrogen, and sulfur. Functional groups are characteristic arrangements of atoms and bonds that function in a specific way in chemical reactions. And chemical properties of a compound are determined by its functional group. So the hydrocarbon functional group are functional groups made of just carbon and hydrogen. Alkanes are not classified as a functional group though, since they undergo few chemical reactions besides combustion. The other hydrocarbons though are functional groups. We have alkenes, so double bonds, alkynes, triple bonds, and an aromatic ring, or an aromatic hydrocarbon. Tamoxifen is an anti-cancer drug, and we can see the different hydrocarbon functional groups it has. It has 3 aromatic rings and an alkene. It also has 2 heteroatoms, oxygen and nitrogen. So writing skeletal line structures of heteroatoms are a little different than writing skeletal line structures of hydrocarbons. All heteroatoms must be shown as a symbol. All hydrogen atoms with a bond to the heteroatom must also be shown. Only hydrogens bonded to carbons are omitted. So this is the Lewis structure of an ether, and it is carbons bonded to oxygen. As you can see from the skeletal line structure, we still have our carbons as zigzag lines, but we have to write out our oxygen, and then we continue with our carbons. There are no hydrogens bonded to this oxygen, so we don't have any hydrogens bonded to the oxygen. In a skeletal line structure, you can include the lone pairs of electrons, or you can omit them. Either way, it doesn't matter. I usually include them, but in the skeletal line structure, you can omit them if you want. For this alcohol, you can see that we have, for the skeletal line structure, the bond to the alcohol, the oxygen, and we have to show the oxygen. And then there's a hydrogen bonded to this oxygen, and we have to show that hydrogen as well. You can either show it as a bond, so oxygen bonded to hydrogen, or just write it as OH next to each other without the line in between. So for practice, we're going to write some skeletal line structures for the Lewis structures below. Pause the video, and then when you're ready, come back to the video and we'll go over it. So for this first one, we have 1, 2, 3 carbons. I'm going to do 1, 2, 3. We have a nitrogen bonded to a hydrogen. We have to write the hydrogen, and then 2 more carbons. So 1, 2. And then that is our skeletal line structure. So it's exactly the same as before. We just have to write out our heteroatoms. Over here, we have 1, 2, 3, 4. 1, 2, 3, 4. Bonded to sulfur, which is bonded to hydrogen. We also have a branched methyl, so I need to put my branch there. So functional groups are characteristic arrangements of atoms and bonds found in many molecules, and they undergo predictable chemical reactions, and they determine the physical properties of a compound. The hydrocarbon functional groups include the alkene, alkyne, and aromatic ring. Alkanes are not functional groups. In skeletal structures, the heteroatom labels must be written, as well as all hydrogens bonded to the heteroatom. And non-bonding electrons can be omitted in skeletal structures, but they are understood to be present.